Let's do the last part for question 9. Right, it says calculate the minimum length of the line segment MN parallel to the y-axis, that can be drawn from G to F. Right, so what is the meaning of this? How can we find this? So here we have to apply calculus. Remember the maxima and the minima. Okay, if we derive our function and equate it to 0, then we can find the x value where our function is going to be minimum. Okay, right now, so mn is actually the difference between g of x and f of x. Right, it's actually the difference between g of x and f of x. So if you say g of x minus f of x, we are going to get our mn. And then we are going to what? To differentiate, find the derivative of that difference, get the x value. That x value we substitute into the function, the difference, to get what? That minimum length. Okay, right, let's try to do it. So the first part now is to find mn, which is g of x minus f of x. So g of x minus f of x, that is mn, is equal to g of x is x plus 8, right? And then minus, be careful, we are subtracting this other function here, so we have to put it inside the bracket, minus negative half x squared minus x plus 4. Okay, and then g of x, or even if you write mn there is fine, minus f of x is equal to x plus 8. Negative times negative is positive, so it's positive half x squared. The negative times negative is positive also, so the negative and positive is negative. Right, now we can collect the like terms and simplify our difference, g of x minus f of x. G of x minus f of x. Right, and then which is equals to, now we have x's, we can add them, or the x squared one is just this. Then x plus x is 2x, so it's plus 2x. And then 8 minus 4, that's plus 4. Okay, right. And then we find our, let's call it mn, or even if you say y is fine. Mn is equal to half x squared plus 2x plus 4. Right, even if you say half is fine, let's derive this. So I can say dmn, even if it's dy dx, it's okay. So dmn, but dx is equal to what? We're deriving here 2 times half is 1, and then 2 minus 1 there is what? Is 1. So we're remaining with x here. And then plus the derivative of 2x is 2. Okay, you can refer to the lesson on what? On the differentiation using rules. Right, but you should be understanding what you're doing now. X 2 times half, we multiply. Remember, when you're deriving using rules, it's ax to the power n. Then you say a times n, which is an, and then x to the power n minus 1. You see that? Okay, like here we say 2 times half, which is 1, and then say 2 minus 1, which is 1. Then here we say 1 times 2, which is 2, and then 1 minus 1, which is 0. Then x to the power 0 is 1. We remain with 2. Okay, right. And then now this is, we equate this derivative to 0. So meaning that 0 is equal to, because at the maximum, this derivative is equal to 0. So it's x plus 2, meaning that x is equal to negative 2. So this function mn is going to be minimum when x is equal to negative 2. Okay, let's just do that in the next slide so that we have what? A clear space here. Remember, our x is equal to -2. X equal to -2. So mn is going to be minimum when x is equal to -2. So what do? We said our derivative dmn dx is equal to x plus 2, and then we said 0 is equal to x plus 2, then x equal to -2. You see that? Right, so this is our mn. This is our mn. So it means we have to substitute where there's x, we put -2 there. So it means mn, what am I writing now? Mn is equal to half the -2 squared plus 2 -2 then plus 4. You see that? And then we can put this in the calculator. We'll get that mn is equal to 2. That's the length of mn, the minimum length for mn. Done. Okay. All right, let me just check this answer before we move on. This is -2 squared, which is 4. 4 divided by 2 is 2. Then 2 minus 4 is -2. -2 plus 4. Yes, perfect, is correct. Right, and then we're going to meet when we do question 10.